So welcome to Unit 1, Mod 3, Displaying Data, Describing Distributions. We're going to learn about several different ways to display data. We're going to start off with a graph called a dot plot. A dot plot is a bunch of dots, exactly what these are here. And in this particular instance, we're actually going to do this later on. We're going to have a quick little quiz, fun quiz, and what we're going to do is we'll record the number of questions you get correct. Now, what each of these dots represents is the number of questions you would have gotten correct. And all we do is plot them, and you have all the information here in front of you. All this data together is called a distribution. And this particular distribution is displayed using a dot plot. You always title things number correct. And this is just like creating a line, a number line. That's one way of describing data. This data here is quantitative data, which is a number. So we're going to use this graph after we create it to help us describe the overall pattern that we see. And there's certain terminology we're going to use in statistics in certain terms. Basically what we're going to do is something called SOX, where we describe the shape, outliers, center, and spread. And we do this, and basically we look for general patterns, general shapes that exist. And there's certain ones that we see very often, and so therefore we use these terms to describe a distribution. If someone were to tell me something is symmetrical, that means it looks the same on the left and the right. And a lot of times when you say symmetrical, people automatically think of something like this, where it's unimodal and then decreases on this side and decreases on this side. This shape here would also be symmetrical, but most of the time if someone says symmetrical, I want you to think of this picture right here. This is called uniform, where uniform is exactly that. If you know the term uniform, it means that it's the same. To be uniform means the same, so that's what this distribution down here would be. The other types that the other two that we're really going to spend a lot of time on is something called skewed right and skewed left. What happens is a lot of your data is here, but then I have some points way out here that are bringing my data over towards it. It's skewing it towards the right. And a good way to remember this, the dog follows its tail, so is the distribution. So if my tail of my distribution's off here, it's called skewed right. Two other types you'll see: the bimodal, unimodal, trimodal, or multimodal, where there's more than one peak. And when we see those, we just a lot of times will say multimodal or bimodal. But these are the four that we're really going to spend a lot of time discussing. Now the rest of the SOX, we just did shape. We're going to talk about outlier, center, and spread. What is an outlier? An outlier is a point like this that doesn't follow the rest of the data points that we collected. So we have a bunch of data down here. We have this one all on its own hanging out. That's a potential outlier. Later on we'll use a formula to directly identify whether something's an outlier or not. Now you can have high-end outliers, and I could also have something way down here, a low-end outlier. Either way, if it's not following the rest of the data, we call it an outlier. Now, it could be more than one. I can have a couple here. I can have one here. I can have one on each end. Center, the middle or average of our data. A lot of times we use the median. Sometimes we'll use the mean, which is an average, where you add them all together and divide by how many there are. The middle of our data, and just like the median, median in the middle of the road, we look for something in the middle. So what you would do is, in this particular instance, you see, all right, well, where is the middle of my data? What would make this thing? And I can count how many pieces of data I have and cross off one from here, and work my way in until I find the actual middle of my data. Right now, we're just going to talk in general terms, and the middle of my data is about 4. Whoa. I'm going a little fast here. Didn't mean to go through everything like that. Down here, the last thing we're talking about is spread. How spread out are my data points? And what we're going to use right now is just something called a range, where we're going to say we're going to go from our smallest up to our largest. And what we're actually going to do is do the largest point minus the smallest. So 15's here, 1's here. I'll subtract them and I'll say that my range is 14. So whenever I talk about spread for now, we're going to be talking about range. Center, we could be talking about mean or median. Right now, with general terms, where's the middle? Where's the center? And we'll talk about 4. So for our purposes, for today's lesson, when I ask you to describe a distribution, you're going to remember your socks. You're going to give me a shape. You're going to tell if there's an outlier, potential outlier. You're going to use the center. We're going to use the median. Where's my data gathered around? What's the center of my data? And then spread, we will use range. Once I know, and let's say I have more than one distribution and I want to compare those, well, what you do is you use those things that we just talked about, socks, when we describe things. But now we're going to have 2 different distributions that we did all these things for. We collected our socks for both of them. And what I'll do is when I'm comparing things, it's real important to use words such as less than, greater than, or equal to. And in this picture, I'm comparing 2 things. You see this guy here? I said he has a bigger head. His head is larger than his head. I say the person on the right is wearing yellow compared to the person on the left who's wearing blue and orange. Whenever I compare things, I always talk about this one versus that one. So we're going to do that with several distributions. Another drawing we may use to compare distributions would be a stem plot. Stem plots are just like very similar in dot plots. It's usually done with small amounts of data and quantitative data. What I do is I separate them here with a line. And this line here, over here I have my stem, over here I have my leaf. And anytime I do something like this, I want it ordered from least to greatest, going in this direction from least to greatest. I put my numbers in order, and then in here, when I do it, I put this is 15, this is 16, 21, 23, and so on. I always want to represent something using a key. For instance, you may have thought that line 2 meant 32, but in this case, it meant 3.2. So that's why a key is critical whenever I'm creating a stem plot. So in a stem plot over here, I put, in this particular instance, I am putting my whole number, and over here, I'm putting the decimal. Over here, this is 15, so I'm putting my tens, and then I'm putting my units here. So it all depends on how you create it, and you can see them going from least to greatest, greatest to least in this order, but they always go from least to greatest, going from right over to here. Well, that's not true. If you have a back-to-back stem plot, you may see them go. They'll go from, they'll start here and go out this way, but they try to put them in least to greatest in that order. So we'll create several of these. The other last type that you may see is a histogram, and the difference between a histogram and a dot plot is you have a lot of data, and you don't want to just have every single piece of data there because it would be too massive and it becomes cumbersome. So then what we do is we create bins. These are called classes, and all the numbers from 60 to 65 go in here, and I count how many there are, and I build it up this way. That's what frequency means, how often they occur. Now these class widths, I want them to all be the same. When I create these classes, I want anywhere from 5 to 12. Anything less than 5, it really doesn't give me much about what's going on. More than 12, again, it can become too cumbersome. And then what I do is I build this thing by creating a frequency table. How often does the numbers between 60 and 65 occur? How often does 60 to 65 occur? You want to label these things nice and clear, state what's going on down here on your x-axis. Over here you write that this is frequency, have a nice title up top. You want these things to be the same width each time, and then anyone can look at this thing and understand what's going on. Now we're going to create these not by hand, but using a nice, we're going to go in here we're going to go to this website called www.snaplet.com. I'm going to show you how to use that. Matter of fact, I'm going to head out there now. So let's get out of here. And we'll go to that website. You go to snaplet.com and you'll see data analysis. And we are dealing with quantitative variable and it's single group. I go in here, click on enter. And this is raw data. I'm just importing numbers, and I'm just going to show you quickly just to put some numbers, and they don't have to be in order or anything like that. Just separate them by space, and now I have some data, and I'm just creating more, and you will see what I'm going to do down here is, all right, well, actually I put it in the wrong place. Let's do cut, paste, and I'm going to say number correct. And I'm going to go along with if we were creating this from a quick quiz we're going to do. So it says begin analysis. Look what it drew, a nice dot plot for me. Here it is here. And then it asked me to describe what's going on, and that would be what I do. I can draw a histogram. The only thing this doesn't do is it won't create a stem and leaf plot. We'd have to go to somewhere else to do that, but really I really wouldn't do a stem and leaf plot very often where I only have single digits and then tens and 20s. That would be too small. So it's like every graph that you create depends on what's given to you. So for us today, this is what we're going to be looking at. We're going to be creating quickly a dot plot of data that we collect. And we're going to collect data several different ways in class, and we will talk about describing those distributions and comparing them. Thank you.